This is going to be a video on direct and inverse variation. And before we start really doing any problems, let's talk about what both of those are. So a direct variation is of the form y equals kx. So basically, y and x are related by some constant term. This k is called the constant of variation. So an inverse variation is similar, but it's of the form y equals k over x, which means that that some constant is divided by one of the variables. So if we solve both of these for k, it will show us how to determine if a relation is a direct or an inverse variation. So if I solve this for k, I could divide by x on both sides. So I would get that k is equal to y over x. Now that k has to be the same for any y and any x that you choose in a given relation. So if you want to figure out if two relations are if a relation is a direct variation, just take the y term divided by the x term, write down what your ratio is. I'm going to write ratio. And then try the next one and see if you get the same ratio, because all of these k values have to be equal to each other. So if you get the same ratio in every single thing, in every single ordered pair, you know that you have a direct variation. If we solve the inverse variation equation for k, we'd multiply by x on both sides, and we would get that k is equal to y times x. So again, this constant will have to stay the same. So if you take the y and you multiply it times the x, if you get the same thing over and over and over again, you're looking at an inverse variation. So a direct variation is when the ratios are equal. An inverse variation is when the products are equal. And if you ever forget that, you can just really quickly come back and figure it out again by starting with either y equals kx or y equals k over x. So our task here is to determine if it's an inverse variation, a direct variation, or neither. So let's start with this first one right here. First, let's check the ratios, y over x. So 3 over 2. Well, that equals 1.5. Alright, so let's try this one, y over x. 6 over 4. And if you type that into your calculator, that equals 1.5. This is looking good. Again, y over x. 9 over 6. 9 divided by 6 is also 1.5. So because each of these ratios is the same, this one is a direct variation. Alright, let's try this one right here. Again, let's start with the ratios. Y over x. So in this case, we have 4 over negative 2. 4 divided by negative 2 is negative 2. In this one, we would have 0 divided by 0, and you can't really divide by 0. But we know that the point 0, 0 is in any direct variation equation, because a direct variation passes through the origin. So we're going to skip that point and go on to the next one. We're going to take the ratio again, y over x. So 4 over 2. 4 over 2 is positive 2. Negative 2 and positive 2 are not the same number, so this is not a direct variation. Alright, so now let's check to see if it's an inverse variation. So for an inverse variation, I'm going to take y times x. So 4 times negative 2, I get negative 8. And 0 times 0, I get 0. And 2 times 4, I get positive 8. So are these numbers all the same? No. So this one is neither. It isn't an inverse or a direct variation. Alright, let's check this very last one. Let's start with checking the ratio, y over x. So 12 over negative 2. 12 over negative 2 equals negative 6. Alright, let's check the ratio again, y over x. So negative 12 over 2 equals negative 6. This one looks like it might be direct. And then y over x. Negative 6 over 4. Wait. This is negative 1.5, so it's not the same. So this is not a direct variation. Alright, let's check to see if it's an inverse variation. So for an inverse variation, you take the product of x and y. K is equal to y times x. 12 times negative 2 is negative 24. 2 times negative 12 is negative 24. And 4 times negative 6 is negative 24. These numbers are all the same, which makes this an inverse variation. Alright, so you'll see direct variations more often presented as equations like this. If I tell you that y varies directly with x, varies directly, basically all you know from this right here is that y equals kx. Y varies directly with x. And then this says if y equals 6 when x equals 36, what is the constant of variation? This is the constant of variation, this k value. And they're giving you a y value and an x value. So then all you have to do is plug in and solve for k. So if I plug in 6 for y and 36 for x, now I can solve for k by dividing by 36 on both sides. So you'll get k is equal to 1 over 6. 6 over 36 will simplify to 1 over 6. And that's it. You're done with the problem because all it asked for is what is the constant of variation. And 1/6 is the constant of variation. Right, let's look at another one. This one says y varies directly with x. As soon as you see this, write it out. Y equals kx. Y varies directly with x. If y equals 2/3 when x equals 3, find y when x equals 9. So they start by giving you an x and a y value. And now you can use that x and that y value to find the constant of variation. Once you find the constant of variation, you can find any value you want. So let's start with that. Let's start by finding the constant of variation. So y equals 2/3 when x equals 3. Right? So let's multiply, divide by 3 on both sides. So k is equal to, so dividing by 3 is the same as multiplying by 1 over 3. So this right here, I'm just going to write it out here to the side. 2/3 divided by 3 is the same as times 1 over 3. So 2 times 1 is 2, and 3 times 3 is 9. So this is that constant of variation. So once you have a constant of variation, you can rewrite the direct variation equation, but just put k in. So here's our direct variation equation that relates x and y in this case. And this is asking us to find y when x is 9. So if we put 9 in here for x, we want to know what we get for y. So we can just go y is equal to 2/9 times 9, and 2/9 times 9 is 2. So that would be your answer. Now, a lot of you probably realize that if two things are directly varying, if they have a direct variation, they're also proportional. So if you prefer to solve these with a proportion, you can do that. You would just say x over y is equal to x over y. So in the first one, x is 3 and y is 2/3. And y is 2/3. And in the second one, x is 9 and y is a question mark, or x, our variable. Or you could put y there. Actually, let's do that since that makes more sense. Okay. So then you just cross multiply and solve. 3 times y is 3y. 9 times 2/3 is 6. And you can divide by 3 on both sides and get that y is equal to 2. Alright, so you've got a couple of options there when you're dealing with a direct variation. Let's look at one more example because you will usually see these presented as word problems. And these don't have to be scary, because as soon as you see the word varies directly, you know exactly where you're going with this problem. So this says the amount of calories burned varies directly with the amount of time spent walking. So I'm going to write a direct variation, but I'm going to use variables that mean something to me. So we're relating calories and walking. And so we can say that the number of calories varies directly with walking, with how much you walk. So we would get C equals KW. Now, if you use something else, if you use like burn equals or varies directly with time and you use T and B, that's fine. It doesn't matter. Just as long as your variables mean something to you and you know that this C is going to go with calories burned and this W is going to go with walking or time spent walking. All right, so then we just go through the exact same process like we did on the last one. If you burn 27 calories in 10 minutes, how much could you burn in 2.5 hours? So let's try the first one. Put 27 in for calories and 10 in for minutes. And so divide by 10 on both sides, and you get that K is equal to 2.7. So if I rewrote my direct variation equation now, I could rewrite it as C is equal to 2.7 times W, or my time spent walking. Now the question's asking how many calories I burn if I walk for 2.5 hours. Well, we put our time here in minutes, so we need to put our time here in minutes. We can't just put 2.5 in there. So we have to figure out how many minutes are in 2.5 hours. Well, 1 hour is 60, 2 hours, and then a half hour is 30 minutes. So 60 plus 60 is 120, plus 30 is 150 minutes. So if I plug 150 minutes in for the time, I can figure out how many calories I burn. So calories is equal to 2.7 times 150. So calories is equal to 405. And again, if you prefer to solve these as proportions, you could do that. If you solved this one as a proportion, it would look like this. 27 calories in 10 minutes is equal to how many calories in 2.5 hours, or 150 minutes. And so 10 times x is 10x, and 27 times 150 is 4050. And you just divide by 10 on both sides and get that x is equal to 405. Either of those ways work. So I hope this has been helpful for getting you ready for direct variation.